Welcome back, students. This is the session 36 from the playlist of NEET Physics Part 1. The chapter is work, power and energy, and the topic for this session is work done by a force. So, I have taken one question which was asked in the NEET examination in the year 2013, which is based on this topic. So, here the question is a uniform force of given by 3I plus J Newton act on a particle of mass 2 kg. The particle is displaced from the position 2I plus k meters to 4I plus 3j minus 2k meters. So the work done by the force on the particle is. So there are four options here and we have to find the correct one. So the work done, as we all know, is given by F dot S, where S is the applied force and S is the displacement. Now here the initial position of the particle is given by 2I plus k. So the position vector, or we can say the initial position vector, position vector of the particle will be equal to, see, the position vector is it gives you or it defines the position of a particle with respect to the origin. So the initial position vector of the particle will be what? This will be 2I plus k, and the final position vector this is given by 4I plus 3j minus k. Position vector basically defines the position of a particle with respect to the origin. So the initial position vector is equal to 2I plus k, and here this is equal to r1, and the final position vector of this particle is equal to 4I plus 3j minus 2k. Let us say it is equal to r2. So the S displacement will be equal to r2 minus r1, and this will be equal to 4I plus 3j minus 2k minus 2I plus k. So from here I am getting the displacement as 2I plus 3j minus 3k meters. So we have found this displacement vector, which is equal to 2I plus 3j minus 3k meters, and now we have to find the work done. So the work done is equal to F dot S. So work done will be equal to F is 3I plus J dot 2I plus 3J minus 3K. So this is equal to, now 3I dot 2I will be equal to 6I cap dot I cap. Now I cap dot I cap, we all know that I cap dot I cap will be equal to 1, because I cap dot I cap is equal to mod I cos theta. Now the angle between I and I is equal to 0, and the magnitude of this I is 1, because it is a unit vector along the x-axis. So I dot I will be equal to 1. Similarly, J dot J will be equal to 1, and K dot K will also be equal to 1. However, I dot K, I dot J or J dot K, they will be equal to 0. So this will be equal to 3 I cap dot I cap, which is equal to 1, so 6. Now I cap dot J cap, this is 0. I cap dot K cap is also 0. Now J cap dot I cap is also 0. J cap and J cap, this is equal to 1. So this is equal to 3 plus 3. So the work done is equal to 9 Newton meter, which is equal to 9 joules. So the correct option is here is A. So here the most important thing is that we have to use this formula, that is work done is given by F dot S, that is work done is the dot product of the applied force and the displacement. And thereafter we have also found the displacement given by this formula, that is displacement is equal to R2 minus R1, where R2 was the final position vector of this particle and R1 was the initial position vector of this particle. So thank you very much for joining this session, and again in the next session I will be coming up with a different topic, but the chapter will remain the same, that is work, power and energy. So till then, have a nice day. Bye.